Hi everyone, Mike, Terry, and Jamie Schlinkmann here again today, and we want to talk with you about the EcoVert 75. One of the things that we get questioned about a lot when we're out there in the marketplace is how did this turbine, come into being? It's so different than anything everybody's ever seen, so it's very common. So we just thought we'd take a minute here and address that. So Jamie, if you will, how did the EcoVert 75 get started?
Okay, so we've got a long, rich history of building, as you know, industrial automation
Sure.
and machines for different industries, and mostly manufacturing equipment. And our market has gotten over the years very Asia centric for that kind of equipment, because most of the products that we've been involved with, whether it be hard disk drives and mobile phones and automotive assemblies, things like that, have the focus has been move all that stuff to Asia, and it's been harder for us to maintain that business, and or less desirable for us to maintain that business. And so what we did, we started looking at, well, take our capabilities, our ability to the amount of engineering talent that we have, whether that's software or mechanical engineering, our manufacturing resources. We've got a big, manufacturing facility here, lots of machining equipment and things like that. How can we put that to use for things that the Western world, America and our Western world as we know it, need? And that brought us to energy-related products. And so from there, we studied, a few different things, but one of the things we studied is wind power, and how we could fit into wind power. And what we did is we came to the conclusion that there was a sustainable looking market for us in the mid-size space, not the big utility generation space that is largely dominated by Vestas, GE, Siemens, companies like that, but the mid-size market, couple hundred kilowatt range, something like that. Sure. So there was a big opportunity as we saw it for and a sustainable opportunity for us to build machines of that size.
I see. So basically, at this point, right, it seems like you've identified there's a need in the market. So what happens next from there?
Yeah. So identifying the market need, and then obviously talking to people who could use machines like that, and doing research about what the actual needs are, and that it's pretty logical at the end of the day. People. For a machine that's going to power their facility, whether it be a hotel or a school or something like that, that is the mid-scale market, is behind the meter type of generation, or even microgrid generation and things like that, which always turns out to be machines that need to be near people. And being near people, they also need to they need to be quiet.
Sure.
And they need to be hurricane resistant. They need to be bird friendly, and those were the key criteria that we went through. And being around people was key to the whole thing, and lowering the speed of the machine was a key attribute to achieve that goal of being around people.
Sure. So it sounds like you had some criteria, some ambitious criteria, by the way, that you were trying to address. But that's got to go from a criteria into a design. What did that process look like?
Yeah. Well, obviously, not knowing a whole lot about the physics and aerodynamics and things like that about wind power, we wanted to see what work had been done out there, and obviously we did a lot of research, read a lot of papers, looked at a lot of published work out there, both academic and non-academic meaning, you know, what companies are on the market and successful and things like that. And you know, trying to make a slower machine is a tough challenge if you wanted the machine to be to not use a lot of materials and to be storm resistant, because to slow down, that means that the machine has to have basically bigger blades or bigger solidity, but I don't want to get too technical here, but the blades have to be bigger for the overall size of the machine. And you know, we were not, you know, we didn't go into this. There's a lot of evangelical vertical axis people, and we were not coming from that, you know, group. We were just saying, what's the best way to solve this problem?
Sure.
And we came across some material, some papers that were McDonnell Douglas, believe it or not, the aircraft company that, you know, that everybody knows, the DC-10, right? That aircraft company developed a wind turbine back in 1979, and they called it the gyro mill at the time. And we really liked some aspects of that machine, and they developed a mathematical model that was helpful. They validated that model by building a machine. They did a lot of work, and we kind of latched onto that. Their patents had expired, their public domain, which is another positive behind the technology, is that, you know, somebody can't come and say, you know, well, you're interfering with patented technology or something like that. It's basically public domain technology. And you know, we put a lot of effort. We made a new mathematical model, and but the gyro mill is definitely something that drove our design. We even went so far as to meet with the retired engineer who led the project.
Yeah, so I
From
mean,
McDonnell Douglas.
if McDonnell Douglas had, you know, designed and developed the machine, I'm curious why, you know, why didn't they commercialize it? Why wasn't it realized? What happened to the project? Why weren't they successful?
Right, that's a good question. So we wondered the same thing. You know, why isn't this the machine out there that everybody sees instead of these big 3-blade you know, turbines? And there's two answers, I think, to that. One of them is that in 1981-82, the energy crisis ended, and, you know, the driving need for renewable energy was kind of somewhat dead in America. And another one was they had a lot of issues related to motion control, and you know, basically computerized motion control. It was a little bit early. That, you know, today we're experts in the field of motion control, and we've developed a lot of hardware around motion control, and we felt like it was something that we would fill in that gap quite well.
Sure. So just really the advance of technology with microprocessors and
Absolutely.
computers and circuit boards,
Yeah,
and
absolutely.
all those things, and help for the technology to be viable at this point.
Yes.
Nice. Okay, everyone. Well, there you have it, and you know, we appreciate everybody tuning in and watching. And at the beginning, you know, we heard Jamie talk about a few things about, you know, the turbine design constraints being bird friendly and quiet and around people. And you know, we make other videos to talk specifically more in depth about those things. So if you're interested, you know, click on those. But we appreciate everybody tuning in. And in the meantime, get out there and protect the earth. She needs our help.